Yes, tell me.
Next week might be hybrid. أنتي معقول يكون الإكزام إنه في عندك
Not
فكرة؟
next week. Not next week. Maybe the week after.
Okay, thank you.
Okay. An 800 kilogram rigid pile P is driven into the ground using a 300 kilogram hammer H. The hammer falls from rest at a height of 0.5 meters and strikes the top of the pile. Determine the impulse which the hammer imparts on the pile if the pile is surrounded entirely by loose sand, so that after striking, the hammer does not rebound off the pile. So what do we understand by the hammer will not rebound off the pile? This information we can use
It's
it
a plastic collision.
So they will couple together?
exactly. So it's a plastic collision and both will have one final velocity at the end. Okay? So since we have one final velocity, then first we can solve for the linear momentum, conservation of linear momentum for the system of pile plus hammer to get our only unknown first, which is the final velocity. And after this, we can calculate the impulse. Because if you want the impulse between the two, okay, you need to take or the hammer alone or the pile alone. And to not have two unknowns in the same equation, V final and the impulse, you can take first the whole system. When you take the whole system, the impulse you have by action reaction, the two impulses will cancel out, and then you will have just no conservation of linear momentum for P plus H. Okay, and then you can solve for your V final. So you can say the following: taking system P plus H, okay, all external forces are non-impulsive, so you can draw a small diagram. You say, what are the forces and why? I have the weight of the hammer, I have the weight of the pile, and both are for a very short, if you have a very short time, you can consider these forces to be non-impulsive. Okay, so when you consider the whole system, you can say no external impulses along y direction. So I can apply conservation of linear momentum along y. So I can say that mass of hammer times velocity of hammer along y at state 1 plus MP VP at state 1 is equal to, since it's a plastic collision, so they will bound, they will form couple with each other. So you have MH plus MP times V final. This is our equation, okay? Now, what do we know about the initial state? For the initial state, the pile was at rest, so VP is 0. Now, how we get the velocity of the hammer just before hitting the pile? What is the information they gave us? They told us that the hammer is launched from a certain height of, so the initial height is 0.5 meters. And then we released it, and we need the velocity just before it will strike the pile. Which concept we can use here to find the velocity just before striking the pile?
Projectile
Conservation
motion.
of mechanical energy.
Very good. You can use projectile motion if you want, and you can use conservation of mechanical energy. Both are right. Okay, both will give you right results. Okay, so here you can say you can apply conservation of mechanical energy. At the initial state, we have we consider the datum if you want to be on the pile level. So V gravitation is 0 when we reach the pile. And we have that at the beginning, V gravitational 0 is equal to mg times h. So V gravitational 0 is mg times the height, which is 0.5, and the kinetic energy is 0. Okay, So this term will cancel out. Just 1 second, please. Let me remove this. Okay, so the first term will be mgh. We have the height to be 0.5 meters. And the initial velocity is 0 because it's released from rest. Now, as it will move downward, the gravitational potential energy will be transformed into kinetic energy. And once you reach the datum, at the datum level, you have that V gravitational is 0, and you just have the kinetic energy, which is half mv squared. So this will allow you to solve for the velocity just before hitting the pipe. Now, once you get V hammer at state 1, you can replace it in your conservation of linear momentum equation, and you can find the only unknown, which is V final of the system. Okay, and as you mentioned, another solution to give us V1 is using projectile motion, so you can find Vy final also before striking the pipe. Okay, now as we apply conservation of linear momentum, we can find the final velocity. This is the first step. Now we are ready to find the impulse between the hammer and the pile. So we can take the pile as a system if you want. If you take the pile as a system, you can write the following equation. You have the impulse of the hammer on the pile. So this is impulse of H on P. If you consider the positive downward direction and you apply now the principle of impulse and momentum on the pile, you can write initially it was at rest, يعني 0, plus the impulse of the hammer on the pile, impulse of H on P, equals to mass of the pile times velocity of the pile final. So in this equation, the only unknown is the impulse. You can get the impulse, okay? You can also take the hammer as a system. So the impulse by action-reaction will be opposite. So this is the impulse of P on H. They are equal in magnitude, opposite in sense. So you can say I have M H VH1, considering always the positive direction downward. So you have a positive velocity VH1, but the impulse is acting upward. So minus I of P on H equals to MH times V final, okay? Now here, if you add the two equations, the impulse will cancel out and you go back to the conservation of linear momentum, okay? So you can use or equation or this one to calculate I. Any question on this?
Doctor, it was
Yes, I have a question.
Yes.
ليش دايما الفاينل فيلوسيتي تبع اثنيناتهم بتكون قد بعض؟
مش دايما هون لانه قالوا the hammer will not rebound off the pile، يعني ما بقى يزيح عنا. So the
بس
final
هو
they will become one body.
بس مش اول ما يعمل كوليجن، لانه بيكون عنده مثل انه باور كتير قويه ونزل عليه، مثل مش بيطج وبيرجع بيطلع بيرجع بينزل. اما نو
لا، انت في عدة سيناريوز، هو بده يدق فيه اكيد وبده يصير في deformation، بس after the collision اذا ضلوا ملازقين ببعض هيدي plastic collision، اذا رجعوا عملوا separation هيدي منا plastic. يعني if they separate after collision ما فينا نعتبر انه they have same V final.
اوكي
اوكي
Okay, thanks.
لو بس يقولوا لك زي couple together أو this object will not rebound off the other one يعني they will become one rigid body at one velocity. بينما إذا قالوا لك they separate from each other and you need to calculate the final velocities after collision بيكون منه plastic. في يكون elastic إذا كان قالوا لك elastic collision يعني you don't lose any of your energy. إذا قالوا لك you have a case in between هلأ بنشوف how we characterize a case in between. Okay, to characterize إذا بدكم if it's elastic, plastic or in between, we'll define now what we call the restitution coefficient. The restitution coefficient بيعطينا if you want the percentage of the deformed energies that can be restituted. انتو بس يصير في collision actually there will be a certain deformation. Okay, now in case the collision is elastic, this energy of deformation will be restituted back to objects and they will separate from each other without any loss of their total energy. While if you have plastic, this is the maximum loss because all energy of deformation will be lost. And then this is why they will couple to each other and will not be able to separate from each other. While if you have a case in between, after collision, part is restituted and part is lost because of permanent deformation. So then you say, I have a case in between. هلا we'll see how to characterize this. هلا here,
Doctor,
since they didn't give us the time of collision, we cannot find F average. If they want to ask us for the average impulsive force between the hammer and the pile, they should give us the time of collision. Yani if they tell you, for example, the collision take place during 0.1 second, then you can say that F average between the two is the impulse that we calculated over the time delta t. But here they didn't give us any information about the time. So we are just able to calculate the impulse and not the average force. Okay? Any question on this? Okay. Now we'll
Doctor,
consider impact.
Doctor, can
And
you hear
we
me?
will, yes?
نحن previous exercise we considered the impulse as a force adding to the weight.
Added to the weight, no. We considered that the weight is not behind
it's a force.
which one you mean? Which previous problem?
هلا كنا عم نشتغل هلا
The weight
نزل
non-impulsive,
pipe وصار
Christopher.
في بلاستيك.
Christopher, the weight is non-impulsive. يعني ما الامبulse له zero. It's negligible compared to the impulse of the collision force. يعني نحن الويتس ما أخذناهم لأنه we considered them non-impulsive forces.
Then what is the يعني هو related to what is the impulse here؟ ما كتير فهمت كيف
Okay.
حط.
أنت you release the hammer from a certain height وصل بhigh velocity on the pile. This will cause a high force of action from the hammer on the pile. And this force is relatively large, much larger than the weight. That's why its impulse is more important than the weight.
Okay.
It's the only impulsive force هي collision force. أصلاً did they gave you time يعني أنت to be able to calculate the impulse of the weight you need the time of application. Do you know the time of application?
No, I do not.
And you can consider that the weight is really small compared to if you want the force acting due to collision.
Okay, thank you.
Okay.
Yes, thank you.
So now we'll consider the difference between central and oblique impact. Okay. Whenever we talk about central impact, this means that the initial velocities are collinear, are along the same line. However, for oblique impact, the initial velocities have different directions. In case you have the initial velocities along the same line, then you can say that the final velocities will be also along this line. However, in this case, if you have different directions for velocities, then after separation, you have new directions also. So this is the difference between central and oblique impact. In central impact, the direction of motion of mass centers of the two colliding particles will be along the line of impact, while what is the line of impact? It is the line perpendicular to the plane of contact. And if you have two balls and these two balls are directed towards each other, when they meet, you can define the tangent plane. Okay, the line of impact is perpendicular to the tangent plane. Okay, and you can say because the velocities are along the line of impact, so the final velocities will also be along this line. While in this case, if you draw the line of impact, it's not, you have velocity directions different than this line. So this will lead to new directions of velocities after collision. Now, how to find these directions? We need to apply concept of conservation of linear momentum along x direction, or along the line of impact if you want, and along the line perpendicular to the line of impact, no change in velocity. Why? Because the impulsive force is along the line of impact. Okay, so if you take the line perpendicular to the line of impact, if we consider, of course, smooth surfaces, okay, along the line perpendicular to a line of impact, there is no impulse. And if there is no impulse, the velocity will remain the same. Because if you write the principle of impulse and momentum, you have that change in linear momentum is equal to the impulse of the force. So if you don't have an impulsive force in this direction, and y direction here, you don't have change in velocity in y. You only have change in velocity along the line for which we have a impulsive force, which is here the line of impact. Okay. So the particles.
Doctor,
Yes.
do you mean that we don't have VA2Y and VB2Y?
We have VAY, but it's not changing. Hala, we'll discuss this.
Okay, it's the same
Yes,
for
it's the
1 and
same.
2.
It will remain the
Okay.
same. While x velocity will change because of the impulsive force. Okay.
Okay.
So let us take for first the example of central impact. Let us consider that the velocities are along the line of impact and collision will take place. Now, what will happen during collision? We'll have a certain period of deformation, okay? And only at maximum deformation, both particles will have common velocity at the relative, we can say that at this instant of maximum deformation, we can consider to have same V. But after this, you have a restitution phase. What do you mean by restitution? And if this deformation is not permanent, the particles will separate from each other. And when they separate from each other, you can define what we call a restitution coefficient E. If you restitute back the whole deformation energy, then you have elastic collision. If you just restitute a part of it, you have what we call inelastic, but not plastic. So it's you have separation but some losses. And in case you have zero restitution, all energy of deformation is lost, then you have plastic collision and the two particles will not separate anymore. Okay. From here we define what we call the restitution coefficient. The restitution coefficient is defined as follows. It's VB final at state 2 minus VA final at state 2 over VA initial minus VB initial. Okay. Now, please pay attention. All of these velocities are projected along the line of impact. In case it's a central impact, already velocities are along the line of impact, so no need to do any projection because they are already along this line. But if you have oblique impact and you want to calculate the restitution coefficient, you cannot use the magnitude of velocities. You should use the projection of velocities along the impact line. We'll see in examples what do we mean by this. Okay. Now, if you want to do some analysis of this restitution coefficient, as I told you, it represents the percentage of the deformation energy that is restituted back to your particles. If we have plastic collision, what will happen to VB2 final and VA2 final?
They will be equal.
They will be
There will be
equal.
zero.
Exactly. So that's why we say for plastic deformation, no energy is restituted back, zero restitution. And the final velocities will be the same. Okay? Now, if we have elastic collision, do you remember last time when I derived with you the relation for elastic collision? We proved together that for a central impact, for elastic collision, we proved together that VB2 minus V8 plus VB1 is equal to VA2 plus VA1, if you remember. We proved this together last time for elastic collision. So now if I take VA2 to the other side, if I take VA2 to this side and VB1 to this side, I deduce that VB2 minus VA2 is equal to VA1 minus VB1. So in case of elastic collision, what is the restitution coefficient? It's 1. And then I can say that 100% of the energy is restituted to my particle. While if I have inelastic, but not plastic, yani in between, then I can define a certain percentage of restitution. And then general E is given for you, or they ask you to calculate E. Yani they can give you E, they tell you E is 30%. When they give you E, this will give you an equation relating VB2 to VA2. Okay, so I will do examples on this. So restitution coefficient will give me an equation, and always my first equation will be conservation of linear momentum. So I get two equations, two unknowns. I can solve for VA2 and VB2 in case of central impact, of course. In case of oblique, it is more complex, and we'll see what to do then. So now let us consider the case of oblique impact. When oblique impact take place, particles move away from each other with velocities having unknown directions and unknown magnitudes. So I end up with 4 unknowns here. VA2, VB2, which are the magnitude, and the angle θ2 and phi2. Since I have 4 unknowns, I need 4 equations. What will be in general my 4 equations? If I know the line of impact, this will simplify a lot my solution. Why? Because if I know the line of impact, okay, I can say that, and I give you the restitution coefficient. I can apply restitution coefficient along the line of impact. So the restitution coefficient will give me equation number 1. So in general, the first equation is from restitution coefficient. Second equation is by applying conservation of linear momentum along the line of impact. Okay, this is equation number 2. Now, what about the 2 additional relations? If I know the line of impact, I can say that in the perpendicular direction, I have no change in velocity. So I can say that VA1y equals to VA2y. This is equation number 3. And VB1y equals to VB2y. This is equation number 4. So I end up with 4 equations with 4 unknowns. So I can determine VA2 magnitude, VB2 magnitude, and the direction of my velocities. I will do an example on this. Let us first consider the following problem. A bag A having a mass of 6 kilograms is released from rest at θ equals to 0. After falling to an angle of 90 degrees, it strikes an 18 kilogram box B. If the coefficient of restitution between the bag and the box is 0.5 or 50%, determine the velocities of the bag and box just after impact and the loss of energy during collision. So to start with, let us do analysis of the problem. First, the bag is released from this position. So first, before collision, we have a phase of, uh, if you want, downward motion. And during this downward motion, what can we apply? What are the forces acting on the bag? We have the weight.
The normal, the tension of the cable.
ما في normal. You don't
Yeah,
have
the
it.
Conservation of mechanical energy.
mechanical energy.
Yes, you only have the tension and weight. And since the tension is perpendicular to motion, because I have circular motion and the tension is along the radius, so the tension will not do any work. The weight only will do a work. So we can apply conservation of mechanical energy between the initial and final position in order to find the velocity of the bag just before hitting the box. Okay? But here, once it will hit the box, if we draw the velocity, this is the bag. So the contact plane between the bag and the box is the vertical plane. So the line of impact, which is perpendicular to the plane of contact, is along the horizontal. And since the bag velocity at this position is along the horizontal, so I can say that velocity of the bag at state 1 is along x direction. It's along the line of impact. And I can calculate it from conservation of mechanical energy. It will be equal to radical 2g times the height, the initial height, which is 1 meter. So it's equal to radical 2g times 1. So I have the initial velocity along x direction. And for my box, VB initial is 0. So since the initial velocity is along the line of impact, it's a central collision. Okay?
دكتور بس ما فهمت ليه شو عملنا VB1 equal ما فهمت شو صار.
Radical 2G you mean?
Yeah.
Okay. And if you apply conservation of mechanical energy, what can you write? You can write gravitational potential energy at A plus kinetic potential energy at A.
Is equal to gravitational at B plus kinetic at B.
Yes. Okay. What if you take the datum at the bottom? What will be V gravitational at A? مش MGH? Yes, mg times the height. The height is 1 صح؟ يعني mg times 1. Kinetic energy is 0. Equals to على final state VB is 0. And what is the kinetic energy? Half times the mass times VB1 square. الام will simplify.
اوكي فهمت.
Okay. وبناخذ ال 2 to the other side. بتصير V square is GH 2GH. So V is radical 2GH. Okay?
Okay, thank you.
Okay.
Doctor, I have a question.
Yes.
Can we apply here the projectile motion?
Look here, it's not, no. Look here as a final result, it will be similar to projectile, but in reality, you have another force, and you have the tension, but the tension is varying in direction. Yani if you need to prove it, you cannot directly say I can apply projectile motion, no, because you have two forces acting. You don't have only the gravity, you have the tension. So you need to prove that the tension will not affect your result because AY will be varying here. It's not minus G because you have a tension. But in overall, if you integrate over motion, you will get the same result. But this doesn't mean that it's projectile motion because AY is changing here. It's not constant. Okay.
Okay, G. Because we have tension, AY is changing.
Yes,
So
exactly.
it's not constant.
Exactly.
Okay, T.
Yes. So you need to integrate over the path and then prove that you will have a result similar to free fall, but it's not a free fall.
بس نحن هون ما عندنا cable between A and B.
عندنا cable هون attached to A. ما عندنا between A and B بس عندنا cable attached
Okay.
to A, and A is moving, it's doing circular motion.
Okay, with the cable is doing
يعني
this.
عنده AN وعنده AT.
Okay, T.
Okay. Now, second step, we need to solve for the velocities after collision. Okay. So now we know the velocity before collision for both the box and the bag, and we need to find the two unknowns at end of collision. Yani we need to calculate VB2 and V small b2. We have two unknowns, we need two equations. What will be these two equations?
We have the coefficient of
Yes.
restitution.
So first we have the coefficient of restitution. So we can write that VB2 minus V small b2 over, هلا بالايكويشن here, if you did V big B minus V small b numerator, but denominator you do the opposite. And you consider now V small b at state 1 minus V big B at state 1 equals to 0.5. This is your first equation. This is equation number 1. Now, what will be the second equation?
Conservation of momentum.
Exactly. I take the whole system, bag plus box, and I apply on it conservation of linear momentum. Okay. So my equations will be first the equation of restitution, and second the conservation of linear momentum, which is MBVB at state 1 plus MAVA at state 1 equals MBVB at state 2 plus MAVA at state 2. At state 1, the box is at rest, so this is 0. Okay. And I calculated VA1 from conservation of mechanical energy. Then I get my relation, a first relation between VB2 and VA2. This is equation number 1. And another relation between VA2 and VB2 is from restitution coefficient. So I have two equations, two unknowns. I solve for my unknowns. Okay? Now they also asked for the loss of energy. They said, what is the loss of energy during collision? Loss of energy, how can I compute it? From the variation in kinetic energy. Why they just consider kinetic energy? لأنه during the collision, just before and just after, you are in the same place. يعني you didn't change a place to have change in potential energy. So what will only change is your kinetic energy. Okay, so you need to do the difference between T2 and T1. هلا sometimes when we say calculate energy loss, يعني we want to find it in, because we said it's a loss, we find it in absolute value. يعني the loss is T1 minus T2. The loss of energy is equal to 33.15 joule. Okay, and to compute it, we just have to calculate the final kinetic energy, which is half MAVA2 square plus half MBVB2 square, while the initial kinetic energy is only for the bag because the box is initially at rest. So if you do the difference, if you do T2 minus T1, you get a negative result because you lost energy. If you do T1 minus T2, you directly find the energy loss in absolute value. Okay? Now, if it's an elastic collision, of course, the total kinetic energy at the initial state will be equal to the total kinetic energy at the final state, and then no loss during collision. Let us do a problem on oblique impact. So we have two smooth disks A and B, having mass of 1 kilogram and 2 kilogram respectively, colliding with each other with the velocities shown in the figure. If the coefficient of restitution for the disks is 0.75 or 75%, determine the x and y components of the final velocity of each disk just after collision. Okay. So here, we know the line of impact. Knowing the line of impact is a positive thing in our solution, because when we know line of impact, we can say that along the perpendicular direction, since I have smooth disks and I know friction, there is no impulsive force. No impulsive force along y. This means automatically that VAY at state 1 equals to VAY at state 2. The same for B. So this is equation number 1. Equation 2 is VBY1 equals to VBY2. And now we need two additional relations. And we solved for VAY2 and VBY2, we solved for them. All we have to do is to project. And if you look at our figure, the magnitude of VA1 is 3, and this angle is 30 degrees. So VAY2 is plus 3 sine 30. Now for VBY2, you have a negative value. It's minus 1 sine 45. So this is minus 1 sine 45. Okay. We are done with y components. We still have two unknowns. VAX at state 2 and VBX at state 2. And since X is the line of impact, okay, so the first equation will be the restitution coefficient. As I told you, for the velocities and the restitution coefficient, to use the velocities projected on the line of impact. And here, since the line of impact is X, so what is E? E is VBX2 minus VAX2 over VAX1 minus VBX1. This is the first relation between VAX2 and VBX2. The second relation, you can get it from conservation of linear momentum in X direction. If you apply conservation of linear momentum in X for the system A plus B, you get an additional relation relating between VAX2 and VBX2. So you end up like the previous problem with two equations with two unknowns that will give you VBX2 and VAX2. Okay, so let us see together. First, you find components of your initial velocities by doing the projections. Then you say, if you draw the diagram, impulse and momentum diagram,